Okay, welcome to the last log lesson. This is week 4. I'm going to go ahead and call this day 2. And most of this is going to be a review of solving with or without logs. Because week 4, day 1 did solving without using logs. Necessarily, sometimes we did. Okay, and there's one final type of solving problem that I want to show you guys, and that is this example. And what I'm going to have you do is figure out how long would it take to double your money at 9% interest if it was compounded continuously. Now, at first glance, when you read a word problem like this, it looks like I didn't give you enough information. Okay, because the only other time you've dealt with a problem like this, I told you how much it was that you invested. So what I'm going to show you is why it doesn't matter that I didn't tell you what P is. So you have two options. You can make up a p-value. So you could, hypothetically say, okay, well, if P was $100, then if I'm going to double my money, then that makes my ending amount, my A of T, $200. So that's option 1. Okay. Option 2 is to just leave P as it is. And so if you're saying your principal is P and you're going to double your money, that makes your ending amount 2 times whatever P is. Okay. So either way, let's say that I took my continuous interest formula, which was A of T is PE to the RT. Let's say I plugged in 200 for A of T, plugged in 100 for P, and plugged in 9% for my interest rate. Or let's say I just plugged in 2P for my A of T, and I left P for my principal, and I plugged in 0.09 for my interest rate. Either way, my first step in the solving process is going to be division. When I divide this version of the equation, divide the 100 to move it over, I end up with 2 is equal to e to the power of 0.09t. And in this other version, my first step is going to be to divide by p. And so hopefully this illustrates why it doesn't matter what you choose p to be. P is always going to divide out of there, and you will always be left with 2 is equal to e to the 0.09t. Okay? And so at that point, the rest of the steps become the same. Okay? So I now have 2 is equal to e to the 0.09t. I'm going to go ahead and take the natural log of both sides now. And natural log and e are inverses of each other, so they will cancel each other out on the right side. And I will have the natural log of 2 is equal to 0.09t. And then my last step is to divide by 0.09. Okay. And so once again, this is what we would consider our exact final answer. Okay, if possible, if you have access to a calculator, whatever quiz you're taking or anything like that, then yes, you would prefer to type this into a calculator and you would get 7.7 years. And so that would be your answer. Okay, so that's the one final type of solving problem. The other types of solving problems that I want to review okay, technically there's 5, but obviously we're not going to work 5 different examples because 2 of these types I'm about to list are very, very recent. And so I'm just going to tell you what they were, and then you have very recent notes to give you plenty of examples on that. But I do want to review some of the older ones. So one of the types that we've solved in this unit is we have solved log equations that use log properties to be solved. So, for example, one of those might look like this. I'm going to go ahead and move to the next slide because I think I need more room. So, log base 7 of x plus 2 is equal to 2 log base 7 of x. So this is an equation that requires using log properties to solve. And so the first log property that we're going to use in this instance is, in order to cancel the logs and their bases, we need to have just a single log on this side, and we need to have just a single log on this side. And on the right side, we have this 2 out in front of it. That's ruining that. So what we need to do is, our first property that we're going to use is we're going to take that 2 back up to the exponent where it would have come from. And so we will now have log base 7 of x plus 2 on the left side, and log base 7 of x squared on the right side. Now we have a log equal to a log, and they have the same base, and so we can drop the logs and the bases. And so we are left with x plus 2 on the left and x squared on the right. At this point, it just became a quadratic, and so in order to finish solving that quadratic, we need to get it set equal to 0. So I'm going to move everything over to the right side. So that makes it x squared minus x minus 2. And it is a factorable quadratic. It does factor. It factors as x minus 2, x plus 1. And so initially I have yielded 2 answers. I've yielded x equals 2 and x equals negative 1. But remember that you can't plug negative numbers into logs. And so when I take this answer right here and I check it in this original equation, okay, plugging negative 1 in here would have been okay, because that means we would have had a positive 1 inside of that log. But plugging that same negative 1 into that one would not work. So this is tossed out as an extraneous answer, because it would mean we're putting negative numbers into logs, but positive 2 does work in both logs. And so that's the answer we keep. Okay, so that is one type of equations that we have solved in this unit. The next type that we have solved are log equations that can be converted. And you notice I used the word can. Okay, it's just one option. Our other option is to treat it like it's the same type as log equations that use log properties. So I'm going to show you both methods, but first I want to give you the actual equation. So the equation I'm going to be solving is log base 5 of 2x plus 1 is equal to 2. Okay, and so the reason that this doesn't automatically fall into category A is because I do not have a log on both sides. So option 1 is, I'm going to rewrite that equation to show you what option 1 would do. So option 1 is to convert this to its exponential form. So the lasso method, or whatever method you were taught, to convert it to exponential form, and it would convert to 5 squared is equal to 2x plus 1. That's method 1. Method 2 would take that equation and over here on the right side, it would take this 2 and it would multiply it by log base 5 of 5. And the reason that it would do that is twofold. The first reason is that this log has to have the same base as this log. It's the only reason I'm going to be able to drop the logs and bases at some point. But this log also has to be equal to 1. And log base 5 of 5 is 1. And so that means the right side is still equal to 2. Okay, I didn't actually change the value of the right side. But now what I've done is I've moved it back into category A. I can use my log properties to solve it. And so this 2 would move up to the exponent, just like it did in the example for type A. And so I would now have log base 5 of 2x plus 1 is equal to log base 5 of 5 squared. And now I can drop the logs and bases. Any way you cut it, you still end up at the same point. You still end up with 2x plus 1 is equal to 5 squared. So at this point, now the rest of the solving is the same. You would now have 2x plus 1 is equal to 25. You would subtract the 1, so you would have 2x is equal to 24. And then you would divide by 2, and so your answer would be x is equal to 12. And of course, you would check it in the original equation, and it would work. And so you would keep that solution. Okay? And then the last type that I'm going to do an example for, type C, are the exponential equations that need logs to solve. Okay, and we did this in week 2 of our distance learning. Okay, so the example that I'm going to do for this one is 5 times 2 to the power of x minus 4 plus 1 is equal to 36. And of course, with these types of equations, your first technically step is to isolate the exponential. So you want the base and the variable or the exponent isolated. And so my first step actually in this case entails subtracting the 1 and also dividing by the 5. So that's what I'm going to do. So I divide by the 5. And so this is now what I have. 2 to the power of x minus 4 is equal to 7. Okay, now step 2, so be it, is to take the log of both sides. Remember that you can use common log or you can use natural log, but we have been focusing mostly on natural log for the purposes of pre-cal next year. And so I'm going to go ahead and take the natural log of both sides. When I do that, this is now an exponent that wants to move down to the front. When you move this down to the front, it is not going to look like this. Okay? And the reason it's not going to look like that is because what you are saying is that the 4 is attached to the natural log of 2 and nothing else is. And that's not true. Okay? The x minus 4 was the exponent, so the x minus 4 moved down to be the coefficient. So the whole x minus 4 is the coefficient to that natural log of 2. And that will drastically change the order that this equation would solve in. Okay, so it's not this. And then because it is this, our next step in the solving process would be to divide by natural log of 2. And that will get rid of the natural log of 2. So now we no longer need the parentheses on the left side. And so we have natural log of 7 divided by natural log of 2. And then our last step is to add the 4 to move it over. Okay? And so what that means, our final answer is x is equal to natural log of 7 divided by natural log of 2 plus 4. That's our nice, pretty, exact final answer. Okay, if asked, or if you have access to a calculator and you type it in, what you would get is x has an approximate value of 6.8074. Okay, and that is actually the last example for the entire unit. Because the last two types of equations that we have solved, all I'm going to do is remind you what type they are. They're recent enough that I'm not actually going to do more examples. Okay, so type D are the exponential modeling problems. Where you are solving for a variable in an exponent. Because the variable you're going to be solving for is in the exponent, that means you're going to need to use logs to solve it. This was the material that we covered in week 3 of our distance learning. And then the final type are the exponential modeling problems. Where you are solving for a variable that's not in an exponent. And that's the most recent material. That was just week 4, day 1 notes. Okay, so those are all of the types that we have solved in this log unit. Okay,